Welcome to another video of Simple Statistics. Today we are going to discuss about Completely Randomized Design, which is used in agricultural and biological scenarios, or in short we say CRD. So normally if you need to do a experiment where you have a different set of scenarios, so in this example a person needs to check 3 fertilizers, namely A, B and C, on the effect of the plant tomato. So suppose that person has a land, and so he's going to do the experiment on that land where each fertilizer is used for 5 plants or 5 set of plants. So for that he has 15 identical plots where fertilizer A into 5 plots, fertilizer B into 5 plots and fertilizer C into 5 plots. So this arrangement of the land where the fertilizers are utilized randomly. So because fertilizer A is here, again here, likewise there. So 5 plots are there because in this experiment we assume that all of the other factors except the fertilizer is same in the total land. So in order to get the outputs correctly statistically, so the assigning is done randomly. So for that you can use random table also. So after a certain period, that means after the yield is generated from this plant, total tomato yield is taken. So in this experiment, independent variable is different fertilizers, while the dependent variable is the yield of tomatoes. So each of the yield in these plots are collected, and after that we have to use SPSS or any other statistical software to generate the statistical output. Let's see how this can be done in IBM SPSS statistics. Okay, now the data has been collected from all of these plots, and it has been recorded in this table. So here the plot 1 where fertilizer A was used and the yield in kilograms is collected. So we have to arrange the data in this manner in order to be fed into SPSS. If not, the analysis become difficult. So here when feeding to SPSS, we have to code this data because now here this is categorical data while this is numerical data. So in order to do the analysis, instead of this A, we have to add number 1, and here likewise for these 4, that means fertilizer 1, and for fertilizer 2 let's use number 2, and fertilizer C let's use number 3. Okay, now we can directly use the data set. Even we don't need this part. However, let's copy all of these, just copy it, and then let's move on to SPSS. So the version that I am using is SPSS 27. However, this works with all of the SPSS versions, and the process is kind of similar. So we can right click here, and we have to go to the data view, and we can right click, and here we have to go with paste with variable names because we need the variable names also. If not, we have to go to here, variable view, and then manually enter the variable names and the number of decimal places, what is the type of measurement. So likewise you have to select. So, and also there is one special thing we have to do, because under this fertilizer, now since we have added value 1 for fertilizer A, so we have to say 1 is for fertilizer A, 2 is for fertilizer B, and then 3 is for fertilizer C. Okay, so for the analysis of CRD, there are 2 methods. One is the one-way ANOVA and also the univariate analysis. So let's go with both methods and do the analysis. First of all, we can go to one-way ANOVA, and here the dependent variable is the yield and the factor is the fertilizer. And under post-hoc test, we have to select, we can select the LSD because this is needed in order to analyze which variable or which fertilizer differs from the others. And also if you have another significant level, so in this case I consider 95% significant level, or else the alpha level is 0.05, and so if it is different you can specify here. And also this under options, if you need the descriptive details you can put a tick, and also please put the means plot if you need a graphical representation of the different the performance of fertilizers. Okay, let's do the analysis and see how the output is. So here descriptives are there. So under the ANOVA we can see the sig value or the significant value is less than 0.05, which is our value, alpha value under 95% confidence, and here it is less than 0.05. So at a glance we can say the mean values of the fertilizers differs from 1 to 1. So now we have to see which fertilizer is different. Now we have to see which fertilizer is different. For that we can use these multiple comparisons, and here significant values are given. So we can see that all of the three fertilizers when compared with the other two is totally different. And here there is a mean comparison graph also, where you can see the mean value of the yield of fertilizer A is 48, something similar to near to 48, and for B it is something between 51, and for C it is 55. So statistically we have proven that all three fertilizers have performed differently, and C is the one that has generated highest yield. Okay, next let's go with the second method, which is the univariate model. For that we have to go to general linear model and select univariate, where we have to add the dependent variable is yield and the fertilizer goes as fixed factors. And under the model we have to select custom model, the build terms, or in some other SPSS versions it will show as custom here, just custom button. And here you have to select the fertilizer and select the main effect and add it here, and we can continue. And under that after that we have to go with post-hoc, and as we did it earlier also, the fertilizer factor should be added for post-hoc here, and select LSD, and then we can continue on. Also, if you need to specify another significance level, you can select it here. And also if you need any other test such as, and also the descriptive statistics, you can select here. Then once we click OK, we will get the results. So here the similar way, the fertilizer effect of fertilizer is significant, and then there is this each one of fertilizer comparison, and it is also significant. And yes, we forgot one thing, so that is to generate the flow. So we can do that, just put in this fertilizer for horizontal axis, and then add. If we need line chart or bar chart, we can do it. So I'll keep it as line chart, and then we'll go on with it. So a similar kind of graph is there. So we can see that both methods yield the same results, and this is how we can do the CRD analysis in SPSS. And we will meet you again in another video where we will discuss different methods, and also we will make another video regarding how to do CRD analysis in Minitab also. Thank you very much and have a nice day.